All right, so I'm going to walk through last year's STAAR test that we use as our benchmark this year. All right, so question one, which expression is equivalent to 7 square root of 45? Well, this should be the easiest question on our test, right? Because we've learned how to actually solve it algebraically. But again, like we're in test taking mode, man, we're just going to learn how to put this in our calculator, right? I hit my little calculator up here in the toolbar. And I'm gonna figure out, well, what is 7 square root of 45 is about 47 or so, right? 46.9. So now I want to know which one is equivalent. Equivalent means equal. So I just gotta figure out which one of these gives me the same number. So if I type in, all right, 12 square root of 3, well, obviously not the same. All right, 35 square root 3. Again, not the same. So I'm type in 10 square root of 5. So type in 10. We're going to do square root. I hit second and then x squared because that's where our little square root is, but it's in blue. So I get the blue button first. 5. And I get 20. None of these are the same number. So I know it's got to be the last one. But let's just check. 21 square root of 5. So it should equal this same number up here. 46.957. It's the exact same number. So then I know these two are equivalent. There's going to be a question like this in our test. It should be the easiest question. I'm moving on to our next question. All right. The graph of quadratic h is shown in the grid. Which function is best represented by the graph of h? All right. So this is a quadratic. Let's look at our answer choices. So these are all written in standard form. If I can't remember that, right? If I go to my reference chart up here in the toolbar, click on the reference chart. And here's all of our formulas. So scroll down, right? It says, all right, properties of exponents, linear equations. Here's our different types of linears, and here's our formula for slope. But then this is quadratic. So it's written as, well, there's no parentheses, so I know it's not vertex form. So this is in standard form. All right, so I know it's standard form, right? And I know that standard form, well, our C value is our y-intercept. Well, I can't see it on this graph, but I know if it's facing down, there's no way my y-intercept is going to be positive 15. I'm going to go to the strike through. All right, these two are definitely wrong. All right, so now, well, look, we also know how to graph equations in our calculator. All right, we write this down every day in our brain dump. So if I open up my calculator again, all right, I go to y equals, I'm just going to type these in and see which one makes the same graph. All right, negative, got to hit x and then square minus 8x plus, oh, nope, sorry. Go back, minus 15. All right, and I hit graph. It makes this graph right here. Look, my x-intercepts are -3 and -5. This one is 1, 2, -3 and -5. Yeah. My vertex is at -4, +1, -4, +1. They look the exact same. All right, but if I'm not sure, well, let's look at our next one. All right, so if I hit enter, the next one is negative x squared plus 8x minus 15. And the cool thing about doing it online is, look, all of these are going to be different colors. All right, I can graph them both at the same time. Well, the red one is obviously not the same graph. It's on the wrong side of my y-axis. So I know it's not the red one. So it has to be this first one. All right, but if I go back and look at our other two, say I wasn't sure, I didn't know that was the, right, that was the y-intercept. I can just type those in too. Negative x squared plus 8x. Oops, sorry. I'm going to start that over. I'm just going to type it in my calculator. Negative x squared plus 8x plus 15. And I graph it. Well, obviously, look, because look, yeah, the y-intercept is way up here, positive 15. Again, obviously not the right one. So it's definitely this first one. All right, the blue one is minus 8x and minus 15. So again, when they give us a graph and give us equations, we can just graph them and see which one makes this graph. All right, these should be the first two should have been super simple. All right, the value of y varies directly with x when the value of x is 4 and the value of y is negative 12. What is the constant of variation when y is a function of x? And what is the value of y when x equals negative 6? All right, so I'm gonna click on my annotate. All right, so if y varies directly with x, that means I multiply x. That means y equals kx, and k is our, sorry, kx. K is our constant of variation. So that means just what we multiply some number times x to equals y. Well, if y is negative 12, all right, and x is 4, well, that means we multiply it by negative 3 to get negative 12. So that means negative 3 is our constant of variation, right? Just divide it. Negative 12 divided by 4 is negative 3. All right. So then if x is negative 6, right, 4 times negative 3 is negative 12. Well, negative 6 times negative 3 is positive 18. Uh, Clear all my annotations. Yeah, let's clear those. Okay, so that means my constant of variation was negative 3. Because 4 times negative 3 is negative 12. And if that's my constant of variation, negative 3 times negative 6 is positive 18. All right. Some of us probably could have just assumed, like, all right, well, what did I multiply here? I had to multiply this by negative 3. So that's my constant of variation. And then negative 6 times negative 3 is positive 18. All right. Since we had to answer two parts, and this question actually counted for two problems. All right. So, but that one was a little more difficult. So it's not questions we see all the time, but hopefully we could have gotten that one. All right. So which graph best represents a quadratic function that has no real zeros? All right. And we write down all the time and talk about, well, zeros is just another word for roots, solutions, and x-intercepts. Which of these graph has no x-intercept? Well, this one right here that does not hit my x-axis. All right, look at this. That one has 1 0. It hits the x-axis one time. This one has 2 zeros. It's my axis twice. This one has 1 because it's at one time. But we know zeros is another word for x-intercepts. Man, that was another easy question. All right, number 5. An investor deposited money in an investment account that earns interest compounded annually. The function shown models the amount of money in the account in dollars after 2 years. So A of t equals 1550, parenthesis 1.02 to the power of t. Which statement best interprets one value in the function? All right, so hopefully we are out there going, oh, I know what type of equation this is, right? Because when the exponent is x, well, that tells me this is an exponential function. Exponential, right? Whenever our variable is the exponent, right? T is our exponent up here in this equation, right? Oh, sorry, I didn't circle it. There we go. Oh, that was the worst. So our variable is our exponent. That tells me it's exponential. So we talk about it all the time. Well, if it's exponential, all right, let me try this so I can undo those bad circles. All right. So that means our A value is our initial value and our y-intercept. So I know the number in the front is the initial value in the y-intercept. And I know our B number tells me if our data is growing or decaying. Well, this is greater than 1. So if it's greater than 1, well, that's growth, right? And how much greater than 1 is it? Well, it's 0.02 greater than 1. So that is 2%, right? Because 0.02 equals 2%. So let's go to our options. It says the initial deposit in the investment account was 1581. Well, no, our initial value is 1550. So I know it's not A. All right, this is the amount of money in the investment account increases 102% each year. Well, no, it's only increasing by 2%, right? 102% would be 2.02. All right, so it's not increasing by 102%, just 2%. The initial deposit investment account was 1150. Well, yeah, 1550. Well, yeah, again, our A value is our initial value. So C was our obvious answer, right? I know it's not decreasing 2% because it's greater than once. I know it's increasing. So I know this part should have been wrong. All right, so the tricky one might have been B, because it is increasing, but it's not 102%. It's only increasing by 2% because it's only 2% more than 100. Okay, so let's clear all this. So again, it should have been 1550 because we know the first number is our initial value. All right, so which expression is equivalent to 1/3 6x squared y to the second power times 2x to the third y 4 for all values of x and y where the expression is defined. All right, so again, we have on our reference chart, we have all of our exponent rules here. All right. So when I'm raising an exponent to an exponent, right, our power of a power, right, when it's outside the parentheses, well, that means we multiply our exponents. Right? Then later on, when we're just multiplying our two sets, when I multiply, our product rule means we just add the exponents, right? Exponents get different rules than just normal numbers. But our normal numbers do our normal math. Hopefully, you're out there completing our sentence. All right? We always say that normal numbers do normal math. So this 1/3 stays outside my parenthesis. But now I have 6x squared y squared. So our normal numbers do normal math. 6 squared is 36. But now I have to distribute, right? I got to multiply our exponent times our other exponent. 2 times 2 is x to the fourth. And then 2 times 1 is y to the second. Then times 2x3, y4. Okay. Or look, 6x squared, y squared literally means I have two 6x squared y's being multiplied. Okay. Well, 6 times 6 is 36. I have two x's here and two more that makes x to the fourth. One y and another y makes y squared. Well, yeah, that checks out. But again, when it's a power raised to a power, we just multiply, right? Parentheses mean multiply. So we're distributing this exponent to my other exponents. 2 times 2 was 4. 2 times 1 was 2. All right, but now, so we got rid of our exponents. Now our normal numbers do our normal math. So 1/3 times 36 is 12, times 2 is 24. So I know it's not A, and I know it's not C. All right, so now I'm going to switch to a different color. Let's go purple. All right, so now we do our x's. I have 4x's here and 3x's here for a total of 7x's. And then our y's, I got 2y's here, 4 here for a total of 6. So it is B, 24x7, y6. Okay. So again, like that was a harder problem. But I just got to stop and think, all right, normal numbers do normal math. Exponents have their own rules. And if I don't remember them, well, they're in our reference chart. Oh, sorry, I keep coughing, guys. Clear these drawings. We can move on to our next problem. It was B. All right, the graph of a line represented by the equation 5x minus 8y equals 40. Which value represents the rate of change of y with respect to x for the equation? All right, we write down all the time, and we've been saying that rate of change is the same thing as the slope. So that means I just got to convert this to slope-intercept form, right? Because this is in standard form. Again, that's on our reference chart, right up here, linear. This is written in standard form. Here's standard form. AX plus BY equals C. Well, yeah, that's what this looks like. I got X's and Y's on the left, constant on the right. But again, slope is lowercase m. None of these are the slope. I gotta convert it to slope intercept form. So I got to move my x's over and divide by my coefficient. So if I move this 5x to the other side, now it's negative 8y equals negative 5x plus 40. But I don't want negative 8y. I need to isolate the y. So since this is negative 8 times y, I got to divide everything by negative 8. So I can't divide negative 5 by negative 8, but since they're both negative, that makes it positive 5/8 x. Positive 40 divided by negative 8 is minus 5. But all they asked for was the rate of change, which is the slope. So our rate of change is 5/8. Okay. So again, if I knew rate of change meant slope, yeah, all right, well, I got to find the slope. Well, if it's a linear equation, I got to put it in the slope intercept form because then that tells me the slope and the y-intercept. Okay. The first five terms of a sequence are A1 equals 47, A2 equals 33, A3 equals 19, A4 equals 5, and A5 equals negative 9. Based on this information, create an equation that can be used to find the nth term of the sequence. All right, so we're just trying to figure out, well, what's the pattern? All right, so if I'm looking at my values, I'm going, all right, well, it's going from 47 to 33 to 19 to 5 to negative 9. So every time I'm subtracting 14. So since that's what repeats, that's where our x goes, or in this case, n. So every time I'm subtracting 4, right? But this a of 1 means this is our first term, right? If I made a table, like where x is 1, y is 47, where x is 2, y is 33. And the third term is 19, and the fourth term is 5, right? And so forth and so forth. But this is where our y-intercept goes. Well, we know the y-intercept is where x is 0. So if I want to go backwards a step, rather than subtracting 14, I got to go backwards 14, and that's going to be 61. So that means it's negative 14x plus 61 because it's positive 61. Okay. So, well, that ended up being not very difficult. So, like, we may not have known right away. You're like, what is going on? But just stop and think. All right. A of 1 means that's the first term. That's the second, third, fourth, fifth. I can just make a table and then compare my data. All right. Or look, we know how to type a table into our calculator. So if I would have pulled up my calculator and just gone to stat edit and type these in 1, 2, 3, 4, 5. Whoops. 3, 4, 5. And next to 1 should be 47. Next to 2 is 33, 19, 5, negative 9. Oop. Stat edit. 47, 33, 19, 5. Oh, I typed in minus 9 instead of negative 9. All right. So now I hit stat, calc 4, hit enter all the way down. It says negative 14 and 61. Well, that's what we got. Right. And looking at this, I should have known it's linear, right? Because there's no square here. The n is not an exponent. So since it's just regular n, well, that's got to be linear. Again, hopefully we could have just figured out. All right, well, a of 1 means this is the first term, second, third. What's the pattern? Well, it's going down by 14. And then to get the y-intercept, we go backwards 14. So that means 4. Oh, sorry, not 14, negative 14. It's going down by 14. And so we had to start at 61 because now 61 minus 14 is 47. Again, not a simple problem just because it's weird. It's kind of something we don't really see a whole lot of. But if I just stop and think about it, all right, what do these little numbers probably mean? Like, we could have hopefully figured it out. All right, what is the range of the function f of x equals negative x squared plus 60x? All right, this is a hard problem. We've gotten really good at getting domain and range from graphs, and we've gotten pretty good at tables. But man, from an equation, well, that's a little trickier. All right, well, let's stop and think. What do we know about this equation? All right, I know it's a quadratic, it's x squared, right? But I know if my a value is negative, well, I know that my parabola opens down because the negative flips it over the x-axis. Well, that means our vertex, whatever number it is, right, that's our highest y value. So that means all my other y's are below it. So I know it's going to have to be y is less than or equal to some number. Well, in this problem, there's only one that says less than or equal to. So then I know it's got to be D, right? If my A value is negative, it's got to be opening down, right? And we ever had any range that's a normal equation where it's between two values? Well, no. Like I know it's not less than or equal to some number. That doesn't make sense. All right. So let's see. Could I have graphed this? Let's see. If I go to my graph and I type in negative, oh, I can't type in minus. I got to type in negative x squared plus 60x, and I hit graph. I don't know what it is exactly. That really didn't help me any, but I know it came up from the bottom, so that means it's hopefully going facing down, but we really can't see it. All right, so that didn't help us any. So that's why we had to know. All right, if it's negative, it's facing down. So now I know the top is our vertex, and the vertex is the highest y, so all my y's are less than. I'm gonna clear my annotations. I mean, it was less than. Again, when it was an equation, that was harder, but I should know if it's negative, my A value is negative, then it's facing down. So that's the highest Y. All the other ones have to be less than. So we know range are my Y values. All right. A counselor asked college students who had jobs how many hours they worked each week. The counselor then compared the number of hours each student worked and the student's overall grade average. The table shows the data. Based on the correlation coefficient for the data, what type of linear association exists between hours worked and overall grade average? All right, so look, right, where do we go to type in a table? I got to go to stat edit, right? But anytime it's talking about the correlation coefficient, right, I have to use our calculator. The first thing we got to do, so let's open up our calculator, so we got to turn on the correlation coefficient. So I got to go to second, 0. And I got to scroll all the way down to diagnostic on. So I go down. Oh, not too far. Diagnostic on. And I got to make sure it says done on my calculator. So now we're going to go to stat. Once I turn it on, it stays on unless I count on my calculator. So we go in. All right, 15, 30, 27, 25, 16, 20, and 12. Then 86, 72, 77, 83, 87, 90, and 94. Okay. Oh, I always like to do a quick glance. I'm like, oh, that one should have been 90. I should type in 9. Well, that would have messed up our data. All right. So I always do a quick glance, make sure my numbers are right. Okay. So now that I've typed them in, I go back to stat, but now I go over to calculate. So I want my calculator to calculate my data. And then I hit 4. All right, so our R value is negative 0.90, right? We just look at the first two decimals because we want to think about it like it's a percent. Well, if it's negative 90%, man, that's super strong, right? The strongest it can be is 100%. So I know it's negative, and 0.90 is 90%. So that's going to be a strong negative correlation coefficient. So, man, that's a very simple question. As long as I know how to turn on my diagnostic, well, that's just type in a table in our calculator, and we should know how to do that. We go to stat edit, stat calc 4 all the time. Okay. So again, And type in our table and look at our R value. All right, which statement about the graph of y equals 16 0.5x is not true? So again, we're talking about exponential functions. Well, we know, right? Because the x is the exponent. Well, we know the number in the front is the initial value and the y-intercept. So the y-intercept is 0.16. That is true, right? The graph is decreasing. Well, yeah, our b value is less than 1. So that is decreasing. So that again, that's true. The x-intercept is 0.5 comma 0. Well, that's the one that's not true. Again, because remember, for our exponential functions, remember it's getting decreasing and it gets really, really close to 0, but it never actually equals 0. So there is no x-intercept. Right? Because think about it. Zero point 0.5 is 1/2. Well, if I keep dividing by 2 every time, over and over and over, my numbers keep getting smaller and smaller and smaller, but they're never going to actually equal 0, right? So that means our horizontal asymptote is y equals 0, right? Because that's where our graph flattens out. Our graph flattens out at 0. It gets really, really close to 0, but never actually touches it. All right, so let's see. Could we have graphed this? Well, I mean, I know we can, but that would have helped. So let's see. If I go to my calculator, I go to y equals, right? Because anything, look, it says y equal right here. That means I'm going to type it in. All right, 16 parenthesis 0.5. Then our exponent is right here above our dividing button. Exponent x. Let's graph it and let's look at it. Oh yeah, see how it gets really, really close? It flattens out at 0 because 0 is our asymptote. Look, at 0.5, does it hit my x-axis at 0.5? Well, no, it does not. So that reinforces this is not the x-intercept, right? 0.5 is our decay factor. It is not the x-intercept. So that one was a little trickier. Like we should have been able to eliminate these first two right away. But the asymptote, still a little trickier. I think we could have gotten that problem pretty easily. All right, what is the solution set that best represents the inequality y is greater than or equal to 1/2 x minus 2? Graph the solution set of linear inequality in the coordinate plane. First, select the graph button to graph the line and choose the line style. To graph a line, select 2 points in the coordinate plane. A line will connect the points. Then select the solution button to select the desired region. All right, so first off, if this is greater than, if it's got the or equal to, well, then I know it's a solid line. So that's good. So now I just got to start with my y-intercept. My y-intercept is -2. So on my y-axis, I put a dot and -2. Well, now my slope is 1/2. So that means I go up 1 over 2. And it makes the line for me. So I just got to start at the y-intercept and use the slope to find my next point. So now we got to choose our solution set. Well, we know anytime it's greater than, we shade above our line. So this is our solution set. All of these points make this inequality true. All right. Two customers purchase coffee and donuts at a coffee shop. Each cup of coffee costs the same amount, and each donut costs the same amount. The first customer paid $4.90 for one cup of coffee and two donuts. Sorry. The second customer paid $8.60 for two cups of coffee and three donuts. What is the cost of one cup of coffee? All right. So this is going to be a system of equations. We got two different equations, right? Our first one is I'm going to say one coffee plus two donuts equals $4.90. Another one is, well, two coffees and three donuts equals $8.60. All right. So now I want to eliminate one of my variables to solve for the other one. So remember, we can't solve for both variables at the same time. I can only either solve for coffee or solve for donuts. But look, what makes this problem tricky is, man, it's going to be easy to eliminate C's because I can just multiply this top equation by -2. But why do I not want to do that? Well, because I'm trying to solve for coffee. Well, if I'm trying to solve for coffee, that means that I would eliminate the D. I want to eliminate donuts. But two doesn't go into three. So that means we get to change both equations. Or I could solve for coffee, then substitute it back in to solve for donuts. But I don't want to do that. So I'm going to multiply this entire top equation by 3 because 3 times 2 will make that 6. And then I'm going to multiply the entire bottom equation by -2 because -2 times 3 will make that -6. And +6 and -6 eliminate. And that's the whole point. So 3 times 1 is 3c plus 6d. And then 4.90 times 3. All right, well, 4.90 times 3 is 14.7. It's 14.7. So I'm going to multiply this entire bottom equation by -2. I get -4c minus 6d equals 8.6 times -2 is -17.2. So now when I combine my equations, oops, when I combine them, well, my donuts eliminate was the whole point. So I get -1c equals -2.5. Well, if -1c equals -2.5, so we divide both sides by -1. So that means coffees cost $2.50. Well, yeah, that's our A value. So that worked. Coffees cost $2.50. So we had to eliminate, right? We could have eliminated the coffee and solved for donuts and substituted it back in, right? We could have totally done that. But I promise you, whatever the donuts cost, I bet you that's one of the answers. Okay. Well, let's try it out, right? So this one cup of coffee costs 250. Well, 4.90 minus 250 is $2.40. So that means two donuts cost $2.40. That means each donut was $1.20. And guess what? $1.20 is one of our answers. All right. They didn't ask us for donuts. They asked for coffee. So I have to make sure I solve the one they actually asked about. Because it'd been way easier to eliminate C. But then if I would have gotten 1.2, I've been so excited because my answer's over there. But I would have missed it because I didn't answer the question they asked. All right. So look, this was a harder problem, right? Systems take a little bit of work, but they give us this data. We should be able to written our two equations pretty simply, then make sure we're eliminating the one that we don't want. All right, guys. So this is gonna be the end of this video because this period's about to be over. So I'll start up with my next one, starting with problem 14. All right. Hope this has been helpful.